Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today we present my research paper on leakage detection and localization using wireless 3-axis vibration sensor. My name is Muhammad Ismail Faizal bin Muhammad Ismail. I am PhD student at Razak Faculty and Technology, Razak Faculty of Technology and Informatics, University Technology Malaysia, Kuala Lumpur. Other researchers is Airo Azizi Awaldah, Dr. Azul, Dr. Rozi Dato Akmal, Dr. Nelidia, Dr. Robiah, and Dr. Nur Azrati Ahmad. First, pipe leak. Pipe leakage come from two factors of water losses. So the first water losses is physical losses, which is pipe burst or pipe leakage, particularly the old asbestos cement pipe. And second is commercial losses, which is inaccurate meter reading, the water thief by illegal tapping, and a maintenance of the water supply. Okay, for the inaccurate meter reading, means that the quantity of the water usage by all meter is less than actual. And for maintenance of the water supply system, which is for example is pipe flushing after leakage repair work, reservoir cleaning, and breakage usage. The problem statement of this research is first, leakage detection method, which is before this nowadays they use acoustic for the method, but the acoustic method very accurate to detect leakage on the metal pipe. Second is vibration sensor. Which is location of the leak, and we can identify the location of the leaks with two sensors. And third is analysis. Now they use single axis for analysis. Okay, for the acoustic, for improve for the acoustic method on the PVC pipeline have a problem, which is because the PVC pipeline is soft and elastic, it will be absorb the sound from the leaks. So that's why in these studies we propose the vibration sensor. Okay, for localization, we use cross correlation analysis. For example, for this research, we apply cross correlation analysis. We did two wireless sensor data for the identify location of the leak point. And this research we use 3 axis. For example, for single axis, normally they put the sensor is parallel with the water pipeline. The axis is parallel with water pipeline. This research objective is to investigate the application of the cross correlation technique in localization the leakage in ABS pipe using wireless 3-axis vibration sensor, which is we use the accelerometer sensor ADXL335. In theoretical, we can identify the leakage location using this equation. Distance equal to distance between sensor minus wave speed multiply with time difference divided by 2. So we can get the location of the leak point. Okay, our test bed have the water flow sensor to identify the water flow inside the water pipeline. However, we need to find out the wave speed from the water flow data. So we using this equation. Wave speed is equal to water flow divided by pipe area. So we use the pipeline size is 1 inch equal to 0.25. Okay, there is our water pipe leakage localization test bed. First, we have valve. The function of the valve is to control the water flow and water pressure inside the pipeline. Second is pressure gauge. Pressure gauge to monitor to measure the pressure inside the pipeline. There is water pump. The function of this water pump to give the water flow rate and water pressure inside the pipeline. Okay, there is parameter to measure the flow rate water. Next is ABS pipe, and then there is vibration sensor. Vibration sensor we use accelerometer wireless sensor through ZigBee. So we use accelerometer ADXL335 in this research. So we use two wireless sensor then we vary the distance between leakage from the 0.5 to 2.2 meters. Okay, there is the leakage simulation. So we set, in this case, leakage is 1 mm diameter. Okay, there is the data analysis. To analysis all the data from the sensor in offline. Okay, there is water tank to give supply water to the system. Return host. Okay, there is experiment parameter. We set the leakage size is 1 mm as I asking before. We use the ADXL335 as a accelerometer sensor. So through ZigBee module, we use ZigBee Pro module. So interface with motor, valve, and water pump. Okay, the sensor distance, we set distance from the leakage point is 0.5, 1, 1.5 and 2. And then the water pressure we vary from the 0.6 kgf over cm squared, 1.0 and 1.3. Okay, the result we get from our experiments. Okay, the top one is the no leak cross correlation data, and the second one, the bottom one is leakage leak at x-axis. So we can get the time difference over here. Okay, next, there is the data from the y-axis, same. We apply on 1 mm leakage size. Okay, there is the z-axis. So in this case, we analyze x, y, z axis. So we analyze 3 different axes to identify which axis is give the accurate data. Okay, there is the result we get. For example, we go to 0.6. We can identify the leakage. The distance is 0.49 to 0.51 based on the data below. So we get the difference is between 0.01 meters. So all the data, we can conclude that the leakage location error using this technique, so is 2.9%. So very low leakage. So this technique can detect, can identify the leakage location. Okay, the conclusion is, first is 2 vibration sensor can detect the leakage in ABS pipeline in all the 3 axes regarding the leakage distance and the water pressure. Second is the ADXL35 vibration sensor only provide high accuracy of the calculation leak location for certain water pressure, sensor distance and limited axis. Therefore, this our recommendation to improve the equation. We need to add time buffer. Time buffer come from the time to send the data through wireless communication. Okay, thank you.